Paragraph 4. Wonderful. Everything you need to know about the cube and its slightly different twin brother, the cuboid. Both of them are 3D shapes or solids. In this paragraph, I will also teach you how to draw a cube in 3D. Again, you will need your protector triangle for these exercises, and don't forget to draw with a pencil. Let's start with the difference between the two. The difference between a cube and a cuboid is the same as with a square and a rectangle. With a square, all sides have to be of equal length, while a rectangle side can be different. The same rule applies to a cube and a cuboid. With a cuboid, the sides don't have to be of equal length. So this here is cuboid ABCD EFGH. Every vertex has a letter, so we start bottom left corner and go counterclockwise. Now, I know that you would like to name this point C, but this one is actually F. This one is C. This one is vertex D. We do this so A, B, C, D are at the bottom of the cuboid and E, F, G, H are at the top. The line segment in a 3D shape are called edges. So this is edge BC and this is edge AE. If we are going to look at the bottom part of the cuboid, ABCD, we call that side of a 3D shape a face. So this is face BCGF and this is face ABFE. I know what you're trying to say, but what about the alphabetical order? Why is it ABFE and not ABEF? That's because we use the edges to go from one point to another. So from A to B to F to E and back to A. All the other times we will be respecting the alphabetical order. Every cube and every cuboid has 8 vertices, 6 faces and 12 edges. Most notable examples of the cubes are dice and the famous Rubik puzzles. The world record for solving a 3x3 Rubik cube is less than 4 seconds. I am never going to achieve such a thing. But if you can solve such a puzzle, great! Good for you! Pat yourself on the back and keep being awesome. If you're ready, let's continue with this video. Besides the edges, you can also draw a line on one of the faces of the cuboid. If you draw a diagonal on a face, we call that a face diagonal. If I were to draw a line segment through the cuboid, so from A to G, we call it a space diagonal. While we're on the subject of lines, in the first paragraph I've taught you about line types and intersecting lines. Lines that never intersect are parallel, and if they are intersect, they can do that perpendicular. If we're talking about a 3D shape, such as the cuboid, lines can also be skewed to one another. Let's look at cuboid ABCD EFGH, shall we? Line segment AB and EF are parallel to another. Edges AE and CG are also parallel to each other. Line segments BC and CD are intersecting lines because they intersect in vertex C. However, line segments AB and CG are not intersecting, or are they parallel? Those two lines are actually skew. In the drawing, it looks like they intersect here, but in reality they do not, because CG is actually behind AB. Now that we know how these lines work, let's draw a cuboid for ourselves, right? I did promise you I would teach you that. Let's make a cuboid ABCD EFGH. with AB equal to 5 centimeters, BC equal to 4 centimeters, and EA equal to 3 centimeters. If you have to make a cuboid to actual size, it would be best to start with a sketch, especially in the beginning. It's not mandatory, but hey, no harm, no foul. There you have it, a beautiful sketch. The letters should be placed like this, and that should give us more insight into the dimensions of this cuboid. This edge should be 5 centimeters, BC is over here and should be 4 centimeters, and AE is this vertical line and should be 3 centimeters. To draw a cuboid, I advise you to start with the front face ABFE. It's a rectangle with a side of 5 centimeters and a side of 3 centimeters. Let's start that one first. We move our sketch slightly to the left and pick a blank spot in our notebook. Make sure you have enough space. Let's start here in vertex A, and we will be going counterclockwise to make the rectangle. Next is the line segment from B to C. It should be 4 centimeters. But we are not going to draw it as 4 centimeters. Because it's the depth of the cuboid, it has to go diagonally. And we're also going to make it shorter. Because if I'm going to draw it 4 centimeters on this side, you immediately see that there's something wrong. So what we want to do is create an illusion of 4 centimeters. To do that, we're going to make it almost 2 centimeters. We start at point B and count 2 centimeters to the right. Then we count 1 centimeter up. And if we were to name this point C and connect it with B, we actually get a pretty nice depth line. We do the same for points E and F, so these are the points H and G. And then we can finish the cuboid by connecting C, G and H. Well, this is already a very nice cuboid, but we're not finished yet. Because if you look carefully, we are missing a vertex. We haven't drawn vertex D yet. So let's do that right now. Because vertex D is invisible to us, as it is in the back of the cuboid, all lines going toward this vertex will be dotted. So we make a dotted line over here, and finally one over here. And now we are truly done with cuboid ABCD EFGH. You can perfect it by writing the lengths of the sides next to it. That's it for this video. Now you know everything there is to know about the cube, and you even know how to properly draw a cuboid in 3D. In the next video, I'll teach you what a prism is and what you need to know about a pyramid. See you next time!